back to Mr. Braun's MasterCalc. I'm Madison Goza and I'll be your host for today's class. Today's topic is applications of derivatives. Before we start working with a problem, let's define a few things first.
A function is increasing when f prime of x is positive. Decreasing would be when it's negative. The next term is critical number. A critical number occurs when f prime of x is equal to 0 or it's undefined. Concave up is used to describe a graph when its f double prime of x is positive. Concave down would be when it's negative. Our last term is inflection point. Inflection points occur when f double prime of x changes sign or when f double prime of x is equal to 0.
Now that we've defined our terms, let's get into an example.
In this example, the problem is negative x cubed plus 6x squared plus 63x plus 8. So you find the derivative and set it to 0 to find the critical numbers of x is equal to 7 and x is equal to 3, negative 3, sorry. And then you can look and make like a little picture and see where it's increasing and where it's decreasing. So it's increasing from negative 3 to 7, and it's decreasing from negative infinity to negative 3, and then from 7 to infinity. We can also find the second derivative, doing the same thing, setting it to 0 and find the inflection point, which is x is equal to negative 2. And then we can again make a little depiction of it and find where it's concave up and where it's concave down. So it's concave up from negative infinity to 2 and concave down from 2 to infinity. And then finally we can find the relative max and relative min by plugging in the critical numbers into the second derivative problem, and to find that it's the first one, it's negative 30, so it's relative max, and then it's positive 30, so it's a relative min. Relative max at x is equal to 7, and relative min at x is equal to negative 3. So here's a rough sketch of this function's graph. As a quick recap, you can see f of x is decreasing from negative infinity to negative 3, increasing from negative 3 to 7, and again decreasing from 7 to infinity. It's also concave up from negative infinity to 2 and concave down from 2 to infinity. Finally, the relative minimum of this function is at x is equal to negative 3 and its relative maximum at x is equal to 7.
You may be thinking, what does this have to do with everyday life? But there's lots of real-world examples where this information is useful.
This is just one example that highlights how this information could be helpful. In this example, the article describes a decreasing rate of COVID-19 positive tests in Illinois. In calculus terms, decreasing would mean a negative rate of change, which this article also addresses.
Thank you for joining us today. Tune in to next week's episode of Mr. Braun's MasterCalc. Bye, guys!